Okay, I wanted to do an introduction to or an orientation maybe is a better word, to the proximity gaps paper and how it relates to the soundness analysis for risc-v's protocol and other protocols that use Fry-based commitment schemes. So the main theorem that we end up extracting from this paper is Theorem 8.3, which describes the soundness of the batched Fry protocol. So the error term for this soundness has three terms that are being added together here. This last term, the S here, I'll zoom in a little bit. S here is the number of queries. So this last term here describes a sort of error on the query phase of the protocol. And then these first two terms describe the error on the batching and commit phase of the protocol. And I'd like to say that this is the error for the batching phase and this is the error for the commit phase, but it's actually slightly messier than that. Not a whole lot messier than that, but so roughly speaking, in my kind of conception of this, when we do Fry, we do this batching initially, which has some error associated with it. We have a commit phase, which consists of something very similar to the initial batching. And so we get an error term that arises from each of those rounds of the commit phase. R here is the number of commit rounds. So, and of course, all of these error bounds have some denominator of the field size here. Okay, so let's look a little bit more into the innards of Theorem 8.3 in order to unpack sort of where this stuff comes from and what's going to get changed. In particular, the analysis that I'm currently most interested in is translating this from a soundness bound in the list decoding regime to a soundness bound in the unique decoding regime. And I would like to believe that it's going to be as easy as finding a term here that's associated with the list decoding regime and replace it with a term that's associated with the unique decoding regime. It feels a little bit hairier to that, but hopefully with a little bit more digging in, it will resolve to something as simple as that. So in particular, my expectation is that this term here, this thing to the 7th power, this is the size of the Fry domain, and this term is quadratic here in the size of the Fry domain, all over this row to the 3 halves. My understanding is that this term is going to get replaced with something that is as simple as just a linear term of this D, D0, the Fry domain. So let's look at where this error term is coming from in order to unpack this in more detail.